Circular motion is what this video is about. Equations that you should learn. Make an effort to learn them. As with every topic, you haven't got time to look in the data book. You should know these equations like the back of your hand. Omega equals 2 pi f, omega is 2 pi over t, f is 1 over t, v is omega r, a is omega squared r, a is v squared over r, f res equals ma. Learn them. Flashcards, memory maps, whatever, learn them. Okay, omega is angular velocity in radians per second, t is the period in seconds, a is the acceleration in meters per second squared, f is frequency in hertz, v is velocity meters per second, f res, I always put res, it's the resultant force in newtons. Some fundamental ideas. If an object is moving in a circle, then it is accelerating. Its velocity is constantly changing. It's moving at a constant speed, but because the direction of its velocity is constantly changing, it is accelerating. Because it's accelerating, from Newton's second law, there must be a resultant force acting on it, and the direction of the resultant force is towards the center of the circle. In other words, it is centripetal. Okay, the direction of its velocity is constantly changing. The direction of the resultant force is centripetal. So here are some objects moving in a circle. So what is the resultant force, which is either pulling or pushing the object inwards towards the center? So look at these diagrams, see if you can figure it out for yourself. Pause the video. Okay, so the moon is being pulled towards the center of its orbit by gravity. The hammer is being pulled towards the center by the tension in the chain. A car turning round a corner, it's friction which pushes or pulls it towards the center. Clothes in a washing machine, it's the push of the drum which pushes them towards the center. Electrons in an atom, it's electrostatic attraction. Protons in the Large Hadron Collider, the centripetal force is provided by magnets. Okay, here's an example. The hammer has a mass of 2 kilograms. The radius of the circle is 1.7. It completes a circle every 0.6 seconds. Calculate those quantities. Pause the video, have a go at it. And there's the answers, and I'm sure you got those answers. Thank you. Here's another example. A satellite in a close orbit around the Earth at a radius of that experiences an acceleration of 9.8 meters per second squared. Calculate its velocity, calculate the period of its orbit. So circular motion, when you do satellites, all of these equations will come in handy for them. Pause the video, do it. And there's the answers. Thank you. Here's another one. What vertical forces are acting on the roller coaster as it's going over a hump and as it's at the bottom of a dip? What will be the direction of the resultant force in each case? Think about it. Okay, so as it's going over a hump, the resultant force must be downwards because that's the center of the circle. So the normal contact force gets smaller. In fact, if you go very, very fast over a hump, like a humpback bridge, if you go fast enough, you actually take off. The normal contact force becomes 0. At the bottom, the normal contact force is bigger than the weight. You feel as though you're being pushed upwards if you go at the dip very fast. The resultant force is upwards, which is towards the center of the circle.